All right, welcome. If you're deep into your GCSE physics revision, you know that the equations can feel like a pretty big hurdle. Well, today, we're going to tackle them head-on.
Have you ever looked at that big, long list of formulas and just felt your brain start to fizzle out? Yeah, you are definitely not alone. But stick with me, because by the end of this, we're going to turn that sheet from something you dread into your secret weapon for the exam. So here's our game plan. First, we're going to break down the key equations by topic: energy, forces, and then waves and electricity. Then, and this is the really good part, I'm going to let you in on a huge exam secret about which formulas you actually need to memorize versus which ones they give you. And we'll wrap up by making sure you have the core math skills to really nail those calculations. Let's do this.
Okay, first up, the equations of energy. You can think of energy as the currency of the universe. It makes everything happen. These formulas are how we keep track of it. This one is a big deal. Kinetic energy is just the energy of movement. A car, a football, you running for the bus. If it's moving, it's got kinetic energy. And you have to, absolutely have to, know this one by heart. And pay really close attention to that little squared sign on the speed. It means if you double your speed, you actually get 4 times the kinetic energy. Right, next up is the energy something has just because of where it is. You know, if you lift a heavy box onto a shelf, you've given it gravitational potential energy. This equation tells you exactly how much. M is for mass, H is for height, and that little g, the gravitational field strength, they will always give you that number in the question, so don't worry. This is another one you've just got to memorize.
In everyday life, power means strength, right? But in physics, it's all about speed. It's how quickly energy is used or work is done. A really powerful engine isn't just one that can go fast. It's one that can get up to that speed really quickly. Just remember, 1 watt is simply 1 joule of energy being used every single second.
And look at this. This is your foolproof method for pretty much any calculation question they can throw at you. Seriously, don't just panic and start punching numbers into your calculator. First, list what you know. Second, pick the right tool for the job, the equation. Third, slot the numbers in, and then you calculate. That last step, checking your units, that's what separates the good marks from the top marks.
All right, Section 2, Equations of Forces. We're talking about all the pushes, pulls, and twists that make things move, or, well, not move. Let's build on what we've learned.
Ah, a total classic. People mix up mass and weight all the time. Mass is how much stuff you're made of, in kilograms. Your weight, though, is the force of gravity pulling down on all that stuff, and we measure it in newtons. This super simple formula connects the two. And yep, you guessed it, you need to be able to recall this one in your sleep.
You know, in physics, work has a really specific meaning. If you push against a brick wall as hard as you can for 10 minutes, you'll get tired, for sure. But if that wall doesn't move an inch, you've done 0 work. Work is only done when a force actually makes something move. It's basically a measure of energy being transferred from one thing to another. Now, I'm not exaggerating when I say this might be the single most important equation you'll learn in GCSE physics. F equals ma. It is the fundamental link between force, mass, and acceleration. It's the very heart of how things move. You have to know it. Okay, time to switch gears. Section 3, Waves and Electricity. We're jumping into 2 topics that are just everywhere in the modern world, from your phone to the lights in your room. This is such a neat little equation. It ties together the 3 key things about any wave. Its speed, v, its frequency, f, which is just how many waves pass by every second, and its wavelength, that funny-looking Greek letter lambda, which is the distance from one peak of a wave to the next. This works for everything, from ripples on a pond to the light from a star. If you want to understand electrical circuits, you've got to start here. This basically says that the total amount of charge that's flowed, which we call Q, is just the current, I, multiplied by the time it's been flowing for T. It's simple, but it's absolutely fundamental. You'll probably hear this called Ohm's law. It's so important. It describes the relationship between potential difference, that's voltage, V, which is like the electrical push, the current, I, which is the flow of charge, and resistance, R, which is anything that tries to slow that flow down. V equals IR. Drill it into your brain.
So when we're talking about electricity, we often want to know how quickly it's transferring energy. In other words, its power. And to solve those problems, there are 2 key power equations that you really must have in your toolkit.
So you've got 2 tools here. The first one, P equals VI, is perfect if you know the voltage and the current. But what if you don't know the voltage?
Well, if you have the current and the resistance, you can use the second one, P equals I squared R. You need to know both, and you need to be smart about choosing which one to use.
And now, for what is honestly the most important revision tip in this entire explainer. This is an absolute game changer. It's going to save you so much time and so much stress. Ready?
That's right. You heard me. You do not have to memorize every single equation on that sheet. The exam board, AQA, actually gives you a list of equations in the exam. Your job is to know which ones they give you and which ones they expect you to have memorized. This is the key to smart revision.
And here it is. This is the secret. That column on the left, the must-recall ones, those are your priority. F equals ma, weight, kinetic energy, you need to know them inside out. But the column on the right, the given in the exam ones, they will be printed on a sheet for you. For those, you just need to know what the letters stand for and how to use them. So focus all your memory work on that left-hand column.
All right, final section. Master the maths. Because look, knowing the equations is one thing, but having the confidence with the numbers to use them correctly and pick up every single mark, that's the other half of the battle.
So I want you to look at this like a final checklist. Ask yourself honestly, can you rearrange F equals ma to find a without breaking a sweat? Do you always remember to convert things like centimeters into meters before you put them in an equation? Are you comfortable with standard form and significant figures? Nailing these skills is how you turn your physics knowledge into actual marks on the...
I'm going to leave you with this thought. Try not to see these as just a bunch of random formulas you have to memorize. Every single one of them tells a story. It's a fundamental rule about how our entire universe works. When you look at F equals ma, you're not just seeing letters, you're seeing the story of motion itself.
So there you have it. You've got a plan. You know which equations to focus on memorizing, you know to practice with the ones they give you, and you know which math skills to sharpen. That equation sheet isn't scary anymore. It's an opportunity. Now go do some practice questions. You've absolutely got this.